Hey everybody, Mr. Reeves back with you again. Today we are talking about interpreting the unit rate as slope or looking at slope as unit rate. So just a reminder, slope is the measure of the steepness of a line. Slope is rise over run. It's how much the y value changes as the x value changes. Change in y over change in x. Those are all ways to describe slope. All right, and remember, review, a unit rate is a rate in which the second quantity is 1 unit. So what we're going to be looking at in a proportional relationship, the slope of the line is the unit rate, which is also the constant of proportionality. And we're going to be looking at graphs and tables and equations and words. And so I just want to skip over here and do a quick review of the different ways that we represent a proportional relationship. So this problem right here, problem number 7 on this page in our math book, which is page 519. There it is. Gives a good example of looking at the different ways to represent a proportional relationship. Now, I believe previously I had said there were 3 ways. There was a table, there's a graph, and there's an equation. I did leave off the 4th way, which is words. So right here, if you look at problem number 7, it says a Canadian goose migrated at a steady rate of 3 miles every 4 minutes. So that is a proportional relationship described in words. Okay, so there's actually 4 ways to represent a proportional relationship. There is the words or the verbal way, there's the table, there's the graph, and the equation. All right, so here we go. Let's go ahead and take a look at the table based on the word description of this proportional relationship. So this goose migrates at a steady rate or a constant rate of 3 miles every 4 minutes. By the way, when we have tables like this, x is our input here, y is our output, x we often call our independent variable, and y is our dependent variable. The distance depends on the time, all right? And remember, in our proportional relationships, we can say that k is equal to y divided by x. The constant of proportionality is y divided by x. We can write the equation y equals kx. And if you need to find x, all right, you could take y and divide it by k. Those are all different ways of describing proportional relationships. But let's fill in the table here. 3 miles for every 4 minutes. So 4 minutes is 3 miles. All right. 8 minutes, we've doubled it, so that's going to be 6. If you take a look here, 3, 6, 9, 12, right? So these are consecutive multiples of 3. So these are going to be consecutive multiples of 4. 4, 8, right? 4 times 1, 4 times 2, 4 times 3 would be 12. 4 times 4 would be 16. And you see that this is 4 times 5, which is 20. So this should be 3 times 5, which is 15. All right? So there is a table. There is a table version of our proportional relationship. All right? And if I were to ask you from the table, can you tell me the change in y over the change in x? If you look from there to there, right, it went up 3. And from there to there, it went up 4. And it continues to do that. So that would be 3 over 4. Okay, so there's our table. There's our words. All right, what about making a graph of this relationship? All right, now our graph, what we want to do is we want to take the values from the table and we want to plot them on the graph. Now, some of these points are going to be difficult to plot a little bit because if you look at the scale, it goes by 2, right? 2, 4, 6, 8, 10, 12, and so on. All right, and remember, when you make a graph, you don't have to plot every single point. All right, so if I take a look at these and say, okay, even numbers, what is one that I can plot? Well, I can plot this one right here, 8 and 6, right? So time 2, 4, 6, 8, right? And then the distance is 2, 4, 6. So that's a point that I can get exactly, right? And then 16, 12 is also a point that I can get exactly. 10, 12, 14, 16, 2, 4, 6, 8, 10, 12. All right, and if you remember, proportional relationships on a graph have to meet two conditions. They have to be a straight line, all right, and they have to go through the origin. So if I know that's true, the origin 0, 0, I can start here at 0, 0, and I can draw a line through those 2 points that I was able to graph exactly. I'm going to do my best here to get it as accurate as possible. All right, and that shows the line that's going to go through these points. And now I could kind of just use that line to plot these points. All right, 2, 4, 3, right about there, right? Which makes sense because this is 2 and that's 4, right? So that point is right there. All right, we have 12, 9, 12, 2, 4, 6, 8, 9, right about there, right? We have 20, 15, 20, 2, 4, 6, 8, 10, 12, 14, 15. See how they line up on that line so nicely? All right, so here we go. We had the words, right? This was our verbal description of the proportional relationship. We had the table, we have the graph, and then we want the equation. All right, so they didn't actually ask us for the equation, but I'm going to ask you for the equation. Remember, the equation of a proportional relationship, the one we use, is this one that relates y and x. So y is equal to k times x, right? Well, what is our value of k here? Our value of k is y divided by x. And when you're going to find that value of k, if it's a proportional relationship, you can use any y over any x. Pick any of these you want to, right? So let's just say I did 15 over 20. All right, and then I simplify that by dividing both of those by 5. What would I get? I would get 3/4. Well, what if I chose 9 over 12? Well, 9 over 12, I divide both of those by 3. And what do I get? I get 3/4. All right, so you could see that the value of k is 3/4. Of course, I could have gotten that one right here, and then I wouldn't even have had to simplify it. So k is equal to 3/4, right? So y is equal to 3/4 x. All right, y is equal to 3/4 x. So we had our verbal description, we had our table, we had our graph, and we had our equation. All right, now over here it says find the slope of the graph and describe what it means in the context of this problem. Well, remember, slope, right? Slope is equal to the change in y over the change in x, or if you prefer, the rise over the run, right? It's how much you're going up and down compared to how much you go left and right. All right, so if we take a look on the graph, again, I just want to remind you, you can use any 2 points that you want to on the graph to find slope, any 2 points at all. All right, 0, 0 is a very nice one to start at, all right? And I'm going to use one that's exactly on the grid. So I'm going to go from there, and then I'm going to go to there, all right? So if we look right there, again, I'm using 2 points. I'm using 0, 0, which was not on our table, but remember, every proportional relationship contains the value 0, 0. All right, the origin right there. How much did it go up? It went up 1, 2, 3 boxes. Now it's actually going up 2, 4, 6, right? 6 and 8. This point actually is 6, 8. It's not 3, 4 because we were going by 2s, right? So the change in y over change in x for the points I used was 6 over 8, which when you divide both of those by 2, you get 3/4, okay? So the slope is equal to 3/4. All right, and describe what that means in the context of this problem. Well, guess what it means? It means exactly what it says right here. A Canadian goose migrated at a steady rate of 3 miles every 4 minutes, right? So the goose travels 3 miles every 4 minutes, all right? Now, what we're going to be talking about next is the unit rate. And remember, in the unit rate, you want that second one to be 1, right? So if I were to do 3 divided by 4, I get 3/4 or, excuse me, 0.75 miles per minute. So that slope gives you the unit rate, okay? So just to remind us of all the things we just went over, we talked about 4 ways to represent a proportional relationship. You have the verbal representation, you have the table, you have the graph, and you have the equation, right? And you can find that constant of proportionality by taking any of the y values and dividing them by the x value. You can find that equation by writing y equals that constant of proportionality k times x. And on the graph, when you find the slope, which is the change in y over the change in x, or the rise over the run, that will tell you ultimately the unit rate. All right, the unit rate up 3/4, 3/4 of a mile per minute. All right. Okay, I was going to do this all in one video, but I think I'm going to stop this first video here and just call this one Graphing Proportional Relationships. And then our next video will be on slope and unit rate. All right. Thanks for watching. Until next time, guys. Bye.